Today we shall discuss the interconversions. Interconversions of the alcohols topic. The first question is conversion of primary alcohol into isomeric secondary alcohol. So let us take an example for this. Example is, let us take primary alcohol, N-propyl alcohol has to be converted into the isopropyl alcohol. So when question is given like this, first of all you write down the both reactant and product structures. N-propyl alcohol is CH3, CH2, CH2, OH. This is N-propyl alcohol to be converted to the isopropyl alcohol, CH, CH3, OH. Then what are the steps or reagents involved in this process? Okay, let us see the steps and everything involved. Initially this OH group is to be shifted over here. Normally it is not possible. Direct isomerization is not possible. So OH group has to be removed. So how to remove the OH group? Just by dehydration process. So let us take the CH3, CH2, CH2, OH subjected to the concentrated H2SO4. So there will be loss of water molecule, hydrogen from here and OH from here. So we get CH3, CH double bond, CH2. Then subject this one with the HBr. So hydrogen comes over here and bromine goes the secondary carbon. So that we get the molecule CH3, CH, Br and CH3. Now you can subject this molecule with the aqueous KOH or else silver hydroxide. Both are good nucleophiles. They generate the OH minus, so OH minus attacks over here and removes the bromine. So we get CH3CH, OH and CH3. So these are the steps involved in this particular process. Okay. Now let's take the second question. Second question is about the conversion of primary alcohol into isomeric tertiary alcohol. Okay, let's take an example for this. Example is isobutyl alcohol. So isobutyl alcohol is to be converted into the tertiary butyl alcohol. So first of all write down the structure of this isobutyl alcohol, which is a primary alcohol. CH3, CH, CH3, CH2. This is the isobutyl alcohol is to be converted to the tertiary butyl alcohol. And this becomes very easy, similar to the earlier procedure. Just again dehydration, HBr, just again the same sequence of the reagents are to be used. So let's take the mechanism, it means sequence of reactions. CH, CH3, CH2, OH subjected to the again concentrated sulfuric acid, so that you will get the isobutene. CH3 double bond CH2. Subject it with the HBr. Again, you know the Markovnikov's rule. So again, you subject with the aqueous KOH or AgOH. So see, I am using the silver hydroxide, means I am introducing another hydroxy nucleophile to you, so that I do not depend only on the aqueous KOH, even AgOH also. So finally the molecule shall be tertiary butyl alcohol. Next, let us take the third question. Conversion of secondary alcohol into isomeric tertiary alcohol. Let's take an example even for this also. That is 3-methyl but 2-ol to be converted to the 2-methyl butane 2-ol. Let's write down these. Its structure. 3-methyl butane 2-ol. So that it must be CH3, CH3, CH, OH, CH3. So 1, 2, 3, 4. So 1, 2, 3, 4. Third position methyl group, second position OH group. This is secondary alcohol. Then it has to be converted to this particular molecule. The molecule is CH3, CH3, OH, CH2, CH3. So numbering 1, 2, 3, 4. 2-methyl butane 2-ol. So what must be the sequence? Again, same sequence. You need to follow the same sequence. CH, CH3, CH, OH, CH3. Just use concentrated sulfuric acid. Then you will get the CH3. So hydrogen from here and OH from here. So double bond shall be formed. HBr. So hydrogen here and bromine over here. Because hydrogen goes to the carbon with a double bond carbon with more number of hydrogens. Br, CH2, CH3. Then use AgOH. Even aqueous KOH also. CH3C, CH3, OH, CH2, CH3. So like this we can convert some of the molecules. Now let us take the ascent of series. Means how to increase the number of carbon atoms. Ascent of series. So while doing the ascent of series, you must remember one thing, that we are going to introduce one carbon atom. So higher number of carbon atoms. So to add a higher number of carbon atoms, we must use the potassium cyanide. Potassium cyanide, so that carbon with a negative charge will attack over the alkyl halides, so that it will remove immediate. So whatever the alcohol you are getting, that has to be converted to the alkyl halide. Or you need to use the Grignard reagent. Grignard reagent or Gilman's reagent. These are all very good organometallic compounds which generate the carbon nucleophile. So let us see one conversion. So in this conversion, first of all, let us see one particular molecule, that is conversion of lower primary alcohol into higher primary alcohol. So let us use, because I said cyanide and Grignard reagent, no? So let us use both the process. First one is bicyanide process. So in this cyanide process, let us take an example, lower alcohol, some lower alcohol, that is RCH2OH. This is one alcohol. To this you just add phosphorus with I2 or PCl3, PBr, whatever it may be. But iodine is a good nucleophile, good leaving group, so that we use always iodine, phosphorus iodine. Why? Because it immediately removes the it can easily be removed by the cyanide, as it is a good leaving group. So we get the RCH2I. Then subject with the potassium cyanide. So here number of carbon atoms are increased. Here only one carbon atom, here two carbon atoms are there. Okay. Then it has to be reduced. Use lithium aluminum hydride. So it converts the cyanides to the primary amines, RCH2, CH2 and H2. Then it has to be converted to the OH group. I said already, non-aromatic means aliphatic primary amines will be converted to their respective alcohols OH group just by using HNO2. So HNO2 has the very much importance while converting the primary amines directly to the OH group. This is one of the important reactions, HNO2, so do not forget it. Now let us take the another one, B, Grignard reagent synthesis by Grignard reagent. So by Grignard reagent, in this I'll take the same molecule here, RCH2OH, subject with again phosphorus plus iodine, so that you will get the RCH2I, then subject with the magnesium in the presence of dry ether. So you will get the RCH2MgI. Then we have to prepare the Grignard reagent actually. Means we have converted the alcohol into the Grignard reagent like this. Then in this Grignard reagent, this particular carbon becomes the carbanium. So it has to be attacked over the another carbon to produce the carbon-carbon bond. So for that we want only one more carbon atom. Hence you use the formaldehyde. Takes over here and replaces. This is step 1, and step 2, H2OH plus. So these two steps had been discussed in our regular classes. So it becomes the CH2OH. So like this you can convert two processes are there. One is the cyanide process, second one is the Grignard reagent process. Now we shall see some other questions also regarding this Ascent series. The first one is, how will you make the following? So in that first question is methyl alcohol CH3OH into ethyl alcohol C2H5 direct alkyl, right, or CH3 CH2OH. Second one is ethyl alcohol CH3 CH2OH into propyl alcohol and propyl alcohol CH3 CH2 CH2OH. So I request you please prepare these two compounds using the above two techniques. these two, you can follow any of these processes, either cyanide process or using the Grignard reagent process. So you just prepare and keep it in your notebook. So let's go for the next question. Conversion of lower primary alcohol into higher secondary alcohol. So let us take one lower primary alcohol. Say this is the primary alcohol. It has to be converted to the some CH, CH3, OH. So this is the procedure. Then how to make it? Because here we are not using any dehydration. Means we have to put carbon this side. So that has to be done. So for that we need to follow the method. So initially let us take this primary alcohol RCH2OH and treat it with the PCC or PDC or CAN or MnO2 or DMSO. So many oxidizing agents we have introduced to you already. So any of these oxidizing agents convert the primary alcohol into the aldehyde. Means we are not using the three oxidizing agents. Those are H plus, KMnO4 or K2Cr2O7. This is the first one. Second one is CrO3, H2SO4, acetone. And here K2Cr2O7 also I had introduced. So either KMnO4, K2Cr2O7 or this one. These are the strongest oxidizing agents which directly converts the primary alcohol into the carboxylic acid. But we don't want the carboxylic acid here. And this has to be subject with the Grignard reagent CH3 MgI. Okay, this Grignard reagent acts over here. And these pi bond electrons of the oxygen will shift over there. Magnesium iodine comes over and attached to the oxygen so that we get the OMgI and CH3 has been introduced, and here hydrogen as it is. It will stay there only, H plus H2O. So H this side, OH this side. So we get RCH, OH, CH3. Our required molecule has been achieved. Okay, so this is the primary alcohol into the secondary alcohol. Higher secondary alcohol means higher secondary alcohol in the sense one extra carbon atom is there. That is called as a higher carbon. Now let us take another problem. How will you convert ethyl alcohol into isopropyl alcohol? What is the procedure? So I have taken the methyl alcohol here, normal. Here, so in this place R you put the CH3, then you will get the molecule. So I'll teach that also. Better you practice. So I'll take the ethyl alcohol CH3, CH2OH, PCC oxidation, CH3, CHO aldehyde, and we want only extra one methyl group because two carbon atoms already present. So that is CH3 MgI. This is step 1, and step 2 is H2O and H plus. So that we get the CH3, CHOH, CH3. This is isopropyl alcohol. So now let us see the conversion of secondary alcohol into higher tertiary alcohol. Okay, so let us take an example for this. R dash This is a secondary alcohol. So I would like to convert this particular alcohol into the tertiary alcohol, means one more carbon has to be attached to this carbon. So that R dash says CH3 OH. Then what must be the procedure? So this is secondary alcohol. No? See, primary alcohol to the secondary alcohol to the tertiary alcohol. It is very simple. Primary alcohols are oxidized to aldehyde. Aldehydes react with the Grignard reagent, always gives the secondary alcohol, except formaldehyde. Formaldehyde gives the primary alcohol. Whereas secondary alcohol, if oxidized to the oxidizer, it will be converted to the ketone. Ketones on reaction with the Grignard reagent gives the tertiary alcohol. That is simple concept. So here let us see secondary alcohol, CH, R dash, OH, just subject with the PCC or DMS, whatever it may be. So you will get the ketone. This ketone, because we want one extra methyl group, so use the Grignard reagent. Step 1. Step 2, H2O and H plus. So you will get the R dash methyl OH, tertiary alcohol. So you just replace this both R groups with CH3, CH3, CHOH, again CH3, convert this one to the CH3, C, CH3, CH3 and OH. Same procedure. These two use, you automatically get the product. Now let us see the descent of series. So in this descent of series, let us see the conversion of higher primary alcohol to lower primary alcohol. Now means we are reducing number of carbons, lower primary alcohol. So whenever you want to reduce the alcohols or whatever molecules it may be, all the molecules are to be converted to the alcohols except amines. Alcohols are to be oxidized to the carboxylic acid, then decarboxylation. Okay. So first of all, I'll take one particular one here. See, procedure I am explaining. Alcohol I have taken. Oxidize this alcohol with H plus KMnO4. It becomes the carboxylic acid. Actually, two steps required, means you can use PCC initial aldehyde again PCC KMnO4 again you will get the carboxylic acid. But why unnecessarily showing the two steps? I am showing only single step here. So subject this one with the ammonia. It becomes COONH4 plus ammonium carboxylate. Ammonium carboxylate on heating will lose H2O molecule, so that we get the amide. This is the amide. The two primary amide, means nitrogen is having only hydrogens, no other alkyl groups. Such type of the amides are called the primary amides. These primary amides, when subjected with the KOH Br2, this combination can also be written as OBr minus, or sometimes it may be called as HOBr. Okay, so generally OBr minus. So this reaction has its unique name. You know that the name of this reaction is Hoffman bromide degradation. So amides becomes amines. So when the amides are subjected with this reagent removes this particular C double bond O, keto group will be removed, and finally you will get the amine. Okay, so here this particular carbon group has been removed by using this particular step. So we got the primary amine. Primary amines subject with the HNO2, they give the alcohol. Okay, and one more procedure is there. This is one procedure. The other procedure is you just take the same alcohol RCH2OH and oxidize with H plus KMnO4, so that you shall get the carboxylic acid. Okay, so this carboxylic acid instead of the ammonia subject with the sodium. So we get the sodium carboxylate. Both are salts. Here this one ammonium carboxylate, here sodium carboxylate. Subject with this soda lime. Soda lime means NaOH plus CaO combination is called as the soda lime. This soda lime will remove the carbon dioxide, CO2. Okay, so you will get the here 1 minute, that's correct. So here you will get the some alkane molecule RH, because here COO Na will be removed, we will get the alkane. This alkane on reaction with the chlorine in the presence of the sunlight will give alkyl halide. Alkyl halide on reaction with the aqueous KOH or AgOH, not both, we get the alcohol. But this reaction is more suggestible than this reaction. The reason here is this particular step. Halogenation is not controllable. Once the halogenation begins, even polyhalogenation also may take place. So that is the reason why here actually we are expecting one chlorine is introduced, and more than one chlorine also may introduce over the alkyl group, so that you will get the not the this type of the normal alcohols, you may get the diols, triols, whatever it may. That's why the first method is suggestible. So this is only one way I would like to inform you how the molecules are going to be converted. But this is the best way where you polyhalogenation and this type of the combination of reactions are not at all involved. Now let's take another problem. How will you convert ethyl alcohol C2H5OH into methyl alcohol CH3OH? Okay, so let us see the means here I am reducing the number of same procedure. I will follow the first procedure. CH3 CH2OH, so that H plus KMnO4, we get the CH3COOH carboxylic acetic acid. Subject it with ammonia, first step. Second step is heating, so that directly I am writing the amide and H2. So here first step is KOH plus Br2, Hoffman degradation, and the second step is HNO2. So you will get the CH3OH. Means instead of writing all these steps, I am just writing the reactant molecule reagents. Means once NH3 is introduced, this particular molecule shall be formed. Next heating, so this molecule is to be formed. Next KOH Br2 primary amine, then RNH2 has to be formed, primary amine. Then that NHNO2 gives the alcohol. So instead of writing all, just you are writing like this. Or else the same reaction, generally if we have complete grip over the reaction mechanism and reaction reagents, then you can write this also. CH3 CH2OH shall be converted to this CH3OH. But the most of the people follow this procedure only, as they have complete grip. H plus KMnO4. Second one is ammonia, and here only they will put them heating also. That means second step. If you don't want, directly you put like this, heating. Fourth one is KOH plus Br2. Fifth one is HNO2. So you must know about the products and then the use of these reagents in that particular reactions. Then Instead of writing this every time the product, you will be able to add only single product. Just use the reagent, sequence of reagents. That shall be very good. Next, let us see the conversion of higher secondary alcohol into a lower primary alcohol. Okay, let us take one example. I'll take just normal example, secondary alcohol. So that we shall take the CH3, CH2, CH, OH, CH. This is secondary alcohol. Then subject with the concentrated H2SO4 dehydration process, and heated, there will be loss of water molecules, so that we get the CH3, CH double bond, CH, CH3. Butene is formed. Then subject to the ozonolysis, because we want the primary alcohol, that to lower primary alcohol. So make it to the ozonolysis, so oxygen and oxygen here. So we shall get the CH3CHO aldehyde. So aldehyde, just use the lithium aluminum hydride or sodium borohydride. Then you will get the CH3CH2OH. Number of carbon atoms are reduced. Here lower means not their descending series, just lower one. Means here we reduce at a time 2 carbon atoms. Here 4 carbon atoms are present in the reactor molecule, but the product is having only 2 carbon atoms. So based on the molecules and reactant in a product, you have to select the sequence of the reactions. Now let us see some conversion of ethyl alcohol into various compounds. Means you must know about the ethyl alcohol, and means alcohol complete almost all reactions here it will come. So you must be aware of that. So I shall take the, I'll write with a good handwriting is important, no? C2H5OH. This is our molecule. So this molecule, if it is oxidized means you can take any mild oxidizing agent, PCC, PDC, like this, mild oxidizing agent. So when mild oxidizing agent is used towards ethyl alcohol, what must be the product here? CH3, CHO, aldehyde. So this aldehyde on oxidation always gives carboxylic acid, CH3, COOH. Okay, so this carboxylic acid you subject with the NaOH, sodium hydroxide. This is an acid, this is a base. Then you will get the CH3COONA, and this CH3COONA on reaction with electrolysis. So electrolysis means this particular COONA will be removed in the coal-based electrolysis. Then we shall get the ethane molecule. And if it is subjected to the soda lime, or just use the calcium oxide also, both are enough, then you will get the methane. Okay, then if this carboxylic acid is subjected to the P2O5, phosphorus pentoxide, and heat it, so it's a dehydrating agent. It will remove the water molecule from the 2 carboxylic acid molecule, so that we get the CH3CO taken twice O. That means acetic anhydride. And the carboxylic acid you subject with the calcium hydroxide, means indirectly you are learning the carboxylic acid properties also. So calcium hydroxide, when carboxylic acid is subject to the calcium hydroxide, you will get the CH3COO taken twice Ca, calcium acetate. This calcium acetate on distillation gives important molecule acetone. So acetone on reduction with lithium aluminum hydride gives isopropyl alcohol. Means we have converted the ethyl alcohol into the isopropyl alcohol using this method also. Now subject this particular carboxylic acid with ammonia. Then carboxylic acids on reaction with ammonia gives ammonium acetate. So this ammonium acetate on distillation or heating. So water molecule shall be removed. So you will get the CH3 C double bond O NH2 amide. Now as I said earlier, Br2 NaOH half monobromide degradation CH3 NH2. Why I am explaining all this is it will be very helpful in conversions. So once you see this chart, it will come to your mind. Use HNO2. So it becomes CH3OH, methyl alcohol. Now let us see these ethyl alcohol reactions also. Some of other reactions. You subject ethyl alcohol with the HCl, that means concentrated HCl, anhydrous ZnCl2. This is a Lucas test, but this is a primary alcohol. Do not react with the Lucas reagent, so that higher temperature is required. So you will get the C2H5Cl, ethyl chloride. Ethyl chloride on reaction with the ammonia NH3. So HCl shall be removed. So you will get the C2H5NH2 amine. Again this amine, if you subject with the HNO2, you will get this ethyl alcohol. Now this one on reaction with the KCN, potassium cyanide, C2H5Cn. So this is cyanide on hydrolysis, acid hydrolysis. Cyanides on acid hydrolysis initially produces amides. These amides again undergo acid hydrolysis. So finally gives the C2H5. No? So I'll write C2H5. Here I wrote wrong. So you will get the carboxylic acid plus ammonia. So once cyanides are acid hydrolysis, you can directly give this product. Not amides are not required. But actually amides are the medium in between the products. So here if this cyanide is subjected to the reduction, lithium aluminum hydride, it gives C2H5 CH2 NH2 primary amine. So this one on reaction with the again HNO2. So you must have now understood that what is the role of the HNO2. C2H5 CH2OH. Okay. Now let us see ethyl alcohol when it is subjected to the 110 degrees centigrade in the presence of the concentrated H2SO4. What is the role of concentrated 110 degrees centigrade? It is a primary reaction. Primary reaction means I had explained many times that C2H5OH plus H2SO4. No? So I'll write this H2SO4 as H and HSO4. So water molecule shall be removed from the ethyl alcohol and H2SO4 at 110 degrees centigrade. So you will get the ethyl hydrogen sulfate. This ethyl hydrogen sulfate, again if you heat it to the 160 to 170 degrees centigrade in the presence of the again same concentrated H2SO4, then it will give the alkene molecule. Even ethyl alcohol properties, some other properties I had discussed very clearly in the previous sessions also many times, that if it is subjected with the same 110 degrees centigrade with a concentrated H2SO4 and 140 degrees centigrade concentrated H2SO4 and 170 degrees centigrade concentrated H2SO4. Here you will get the ethyl hydrogen sulfate. Here you will get the C2H5O, C2H5. Here you will get the C2H4. That means CH double bond CH2. Okay. So now Let's finish this one. We got the alkene molecule. Now alkene properties begins. So alkene properties in this sense here, let us see when it is subjected to the ozonolysis, O3. Second one is zinc H2O. Then what molecule? Here it will be broken. Okay. So you will get the formaldehyde. Only one molecule I am writing. This formaldehyde on oxidation. So oxidation means you can H plus K-4 or K2Cr2O7, whatever it may be. You will get the formic acid. Okay. And you subject this alkene molecule with the Br2 in CCl4. So you will get the CH2Br and the CH2Br. And when it is subject with the HBr, means now this is the unsymmetrical reagent, but this is symmetrical one, so that you can write the CH3 CH2Br, and this shall be converted reacted to the sodium dry. This is the again Urge reaction. Now product is CH3 CH2 CH2 and CH3. Now when this is subjected with aqueous KOH, CH2OH, CH2OH, ethylene glycol. So in many ways we will get the this type of the products. So I request you, if you note it down, no problem. Otherwise, anyhow, I'll send this chart to you. So you pause the video for a while, then note down all these reactions. So whenever it is possible, keep on practicing. So when you keep on practicing, afterwards, we are going to solve some other questions. That how I will give is, I'll take ethyl alcohol, oxidize gives the product A. Product A on oxidation gives the product B. B on reaction with the calcium hydroxide. Means I don't mention these products. Only reagent shall come. Calcium hydroxide gives product C. C on distillation gives product D. Okay. D on reduction gives isopropyl alcohol like this. So you must be able to see that here one carbon is increased. 3 carbon atoms are there, here 2 carbon atoms are there. So you will get confused of how this procedure has come. So how means here whenever calcium hydroxide is used, you must understand that primary alcohol on oxidation gives aldehyde, aldehyde also on oxidation gives the carboxylic acid. So come carboxylic acid and calcium hydroxide gives calcium carboxylate. So calcium carboxylates on distillation always gives the aldehydes ketones. I'll show you that reaction also here. Anyhow, that shall be discussed in the coming classes, but here I'll show you how the procedure is going to take place. CH3 C double bond O. 1 minute. O. This is CH3 C double bond O. O. I'll write O here also. Here. Okay. Now calcium is there. This is of what called calcium acetate, CH3COO. No? So this is called the calcium acetate. So when this calcium acetate is heated, heating means a distillation. So when you distill it, it always lose calcium carbonate. So calcium carbonate means calcium, 1 carbon, 3 oxygens. So calcium, 1 carbon and 3 oxygens. Like this. So CaCO3 has been removed. Then what is left here? CH3CO, CH3CO. So these two will be connected to each other. So we get the CH3CO, CH3. Okay. So when calcium acetate is distilled, we get the acetone, ketone molecule. Similarly, let us take now H, C double bond O, oxygen, calcium, H, C double bond O, oxygen, calcium. Now heated distillation. So distillation means always there is a loss of CaCO3. Calcium salts when distilled. So CaCO3 shall be removed, just like a liver structure. Then what must be the product? Hydrogen shall be connected here so that you will get the formaldehyde. So calcium formate this is because HCOO minus is the group. Like the two groups are connected to the calcium because calcium valence is +2. Here each of this one valence is -1, so that two are required. Calcium formate gives formaldehyde, calcium acetate gives acetone. Then what happens if both are combined? Means calcium acetate as well as calcium formate. Then you see this is the product. This is the calcium acetate. This is the calcium formate. So when these two are used, it is simple thing that from both you need to remove the CaCO3. Okay. So here CH3 is left and CO group you have removed from the top. Then you remove the CO from the bottom here. Now you combine CH3, CHO, aldehyde. Here CH3CO and hydrogen, aldehydes. So aldehydes are obtained when calcium acetate and calcium formate. Formate must be present. Formate is there means aldehyde group will be there. And if only formate is not there means ketones. If both are mixed, you will get the aldehyde groups. Okay. Now I'll give some two more tests regarding how to identify, how to distinguish methyl alcohol from the ethyl alcohol. Please note down that is because these are some important. How to distinguish methyl alcohol and ethyl alcohol. Write down methyl alcohol here and ethyl alcohol there. So now you see iodoform test. Iodoform test I had already explained one video. Please check over that video for complete discussion. Anyhow, we also discussed in our regular classes. So heating the compound, organic compound with iodine plus NaOH. Iodoform test basically responds to the compounds which are able to provide the CH3CHOH group. Any compound which is able to provide this type of the group, they give the positive test. So ethyl alcohol is having the CH3CHOH group. So here it gives the positive test, here it gives the negative test. And the second one is Ester test. So in this Ester test, because any alcohol when subject to the carboxylic acid, it forms the ester. Okay. So within these esters and what type of the smell they give. So simply you take the acetic acid, CH3COH acetic acid plus concentrated H2SO4. You add this combination to the both methyl alcohol as well as the ethyl alcohol. Okay. So if the fruity smell comes, then it is ethyl alcohol. If normal other than fruity, some characteristic odor, normal odor comes, then that is the methyl alcohol test. So these are the important tests to identify the both methyl alcohol as well as the ethyl alcohol, simple tests. But best one is always iodoform test, which directly gives the yellow crystals of the iodoform. Because here odor cannot be identified. Similarly, let us see how to distinguish ethyl alcohol from chloroform, CHCl3. Okay, let us take both now. I'll take ethyl alcohol here and chloroform here. Okay, now first again you subject with the iodoform test. Iodoform is the best test to identify presence of ethyl alcohol. But if acetaldehyde is there, then you cannot perform iodoform test. Why? Because both acetaldehyde and ethyl alcohol gives the positive test with the iodoform. So I2 plus NaOH gives positive test, it gives negative test. Second one is isocyanate test. So isocyanate test. So when isocyanate test in this sense, here we take the aniline plus alcoholic KOH. You must remember one important thing here, that even aniline is having the aromatic NH2 group. So to identify NH2, we want this test only. Ethyl alcohol gives the negative test, this gives the positive test. Means aniline primary amine, aromatic primary amine. This is the aromatic primary amine. This is called as carbylamine test or phenyl isocyanate test. So this plus KOH plus chloroform. So this combination gives a very bad smell. That's why it is easy to identify this presence of either chloroform or primary aromatic primary, and both can be identified using the isocyanate test, as it expels the very bad odor. Then how to stop that odor means this KOH has to be neutralized. So we need to add some acid. Then automatically the odor will be stopped. And the last test of this category of this alcohol and chloroform is solubility test. So in this solubility test, you just see ethyl alcohol being OH group is present here, soluble in H2O. But here no such groups are there, so it is insoluble in the water. Thank you for joining today's session. If you understand my explanation, please like the video.